In this video, we're going to talk about electrolytic solutions. Sometimes you hear electrolytes and non-electrolytes. Essentially, electrolytes, there are three types. One electrolyte is a strong electrolyte. And the key to understanding electrolytes is basically strong electrolytes produce a large concentration of ions. They completely dissociate when they're in water. So that allows them to conduct an electrical current. So here we see an example of a strong electrolyte, sodium chloride. Sodium chloride is an ionic compound that's completely soluble in water. When it's placed in water, it dissociates 100%. As a result, there's a lot of ions. Those ions are free to move around and conduct an electrical current. The second type of electrolytic solution is a weak electrolyte. Weak electrolytes only produce a small portion of ions. The majority of the solute compounds are complete molecules with no charge. Remember, it's the charge that's required to produce an electrical current. So with weak electrolytes only producing a few ions, they can only conduct electricity poorly. We see that in this example. So one example of a weak electrolyte is hydrofluoric acid. Hydrofluoric acid is a weak acid and only partially dissociates. As a result, the majority of the hydrofluoric acid is a neutral compound, a neutral covalent compound without any charge. So it only dissociating partially only gives me a small concentration of charged particles, resulting in poor conductance. That's why this light is dim instead of bright, like in the case of the strong electrolyte. The last example is a non-electrolyte. Non-electrolytes are non-conductors. They don't produce any electricity. Why? They don't produce any ions. They do not dissociate into charged particles. So here's an example of a non-electrolyte, sugar. Sugar remains as a covalent compound which is neutral with no individual charges. As a result, if there is not a charge, the current cannot be conducted and there is not a light. We see right here, there is no light. So of the three types that we just discussed, strong, weak, and non-electrolyte, just keep in mind that basically strong electrolytes completely dissociate. There's only ions present, so they're good conductors. What are examples? Soluble ionic compounds. And we also see examples of some strong bases, like in the case of sodium hydroxide, potassium hydroxide. So basically, for a strong electrolyte, you need soluble salts, strong bases, and we'll also see that we see hydrobromic, hydrochloric. We also need some strong acids. Why? Strong bases and strong acids are like soluble salts, and they completely dissociate. Weak electrolytes are ones that are mostly molecules, and they only partially dissociate. As a result, they do conduct electricity, but poorly because they don't have a large concentration of ions. What are examples of weak electrolytes? Weak acids and weak bases. So our examples are hydrofluoric acid and acetic acid. Those are weak acids. Ammonia, that's a weak base. The third type, again, the non-electrolyte, does not produce any ions at all. It's pretty much just molecules with no charge, neutral charge. Doesn't mean they don't dissolve. They're surrounded by the water. They're solvated, and they are dissolved, but there is no charge. And why is there no charge? If you take a look at all these examples, methanol, ethanol, sucrose, urea, these are all covalent compounds. Covalent compounds do not dissociate into ions because they're not ionic compounds. One of the things you do need to know is which acids are strong and which bases are strong. So I always tell students, know the 6 strong acids, know the 6 strong bases. And if you're going to complain, you could look at it this way. You can either memorize the 6 strong acids and 6 strong bases, or try to memorize thousands of weak ones. I think it's easier to recognize the 6 strong ones, and that way any other type is going to be weak. So what are my 6 strong acids? 3 of them are really easy. They're the binary acids: hydrochloric acid, hydrobromic acid, and hydroiodic acid. The other 3 are oxyacids: perchloric acid, nitric acid, and sulfuric acid. So any other acid would not be a strong acid, would therefore not dissociate. All of these dissociate 100%. Any other acid won't do that, and as a result, it will be a weak acid. Weak acids would result in being a weak electrolyte. Some examples of weak acids: hydrofluoric is a weak acid. It's binary, but it is a weak acid. Another example of a weak acid: carbonic acid. Carbonic acid is an oxyacid, but it is also a weak acid. So again, it's much easier to remember the 6 strong. What about the strong bases? I actually think the strong bases are much easier to remember. The first 3 that I want you to look at and remember is look at your periodic table. If you go to group 1A, alkali metals, lithium, sodium, and potassium go down the group. Lithium hydroxide, sodium hydroxide, and potassium hydroxide are all examples of strong bases. If you go to the potassium elemental symbol on the periodic table and move 1 over to the right, that next symbol should be calcium hydroxide. Calcium hydroxide is an alkaline earth metal, but there are 3 examples of alkaline earth metals that are strong bases: calcium hydroxide, strontium hydroxide, barium hydroxide. So you start at lithium, go 3 down on the periodic table, go 1 over to calcium, and then strontium and barium. And that's a really easy way to remember your 6 strong bases. You might have to put a little more effort into the 6 strong acids, but again, it's easier to remember 6 rather than thousands of weak. I hope that helps. Leave any comments if you want in the comment section.